we're going to talk about determining the critical control points. But first of all, let's look at some concepts. Control measures, process controls, and critical control points. Control measures are actions and activities that can be used to prevent or eliminate a food safety hazard or reduce it to an acceptable level. And both process controls and critical control points are types of control measures. They are measures taken to prevent food safety hazards, and the main difference lies in their application and the level of risk they address. Process controls are measures that contribute to the reduction of a hazard, but may not completely eliminate it. They are used for medium to high risk hazards. For example, maintaining a certain temperature during food processing to reduce bacterial growth is a process control. On the other hand, a CCP is a point in the food production process where a control measure can effectively eliminate or reduce a food safety hazard to an acceptable level. CCPs are used for high or critical risk hazards. For example, cooking food to a certain temperature to kill bacteria is a CCP. And then look at validation and verification. Validation is the process of collecting and evaluating scientific and technical evidence to determine if a HACCP plan, when properly implemented, will effectively control the hazards. For example, scientific studies showing that cooking chicken to a certain temperature will kill a certain bacteria would be used to validate a CCP. Verification, on the other hand, is the application of methods, procedures, tests, and other evaluations, in addition to monitoring to determine if the HACCP plan is being followed and if the measures are having the intended effect. For example, checking the temperature of the cooked chicken and reviewing cooking temperature logs would be part of the verification process. The main difference between validation and verification is that validation ensures the effectiveness of the measures in the HACCP plan, while verification ensures the measures are being properly implemented. And then let's look at prerequisite programs. Prerequisite programs, PRPs, are practices and conditions needed prior to and during the implementation of HACCP and which are essential for food safety. Prerequisite programs are the foundation upon which a HACCP system is built. They control the operational conditions within a food establishment, allowing for environmental conditions that are favorable to the production of a safe food. PRPs are generally used to control low to medium risk hazards and are the basic conditions and activities that are necessary to maintain a hygienic environment. Examples of PRPs include personal hygiene, cleaning and sanitizing, pest control, and maintenance of facilities. If a hazard is identified that is not fully controlled by a PRP, then it must be controlled by a process control or a CCP. Therefore, PRPs, process controls, and CCPs work together to ensure all potential hazards are controlled at some point in the process. And after we clear up all the concepts, let's look at how to determine the critical control points. So you should use Form 8 of HACCP manual, answer questions one by one. And there are some traditional processing steps that food processors have determined to be CCPs, including cooking, cooling, dehydration, formulation, pasteurization, and sifting. And there is a simplified CCP decision tree. Ask yourself, if I lose control, is it likely that food poisoning will result? If the answer is yes, then it is a CCP. Let's move on to the third part, establish critical limits. So first, a critical limit is a maximum and or minimum value to which a biological, chemical, or physical parameter must be controlled at a critical control point to prevent, eliminate, or reduce to an acceptable level the occurrence of a food safety hazard. For example, in the cooking of a poultry, a critical limit would be an internal temperature of 165 Fahrenheit or 74 Celsius. This temperature is known to effectively kill common foodborne pathogens like Salmonella and Campylobacter. If the internal temperature of the poultry doesn't reach 165 Fahrenheit, it would pose a food safety risk. And then deviation. A deviation is a failure to meet a critical limit. In other words, it's when a process goes outside the established control measures, potentially leading to a food safety hazard. Continuing the above example, if the internal temperature of the poultry only reaches 160 Fahrenheit, this would be a deviation from the critical limit. The deviation indicates that the cooking process did not meet the established safety safety standard, and the corrective action would need to be taken to ensure food safety, such as continuing to cook the poultry until it reaches the correct temperature. In a well-implemented HACCP system, monitoring procedures are in place to detect deviations when they occur, and there are established corrective actions to bring the process back under control and ensure the safety of the food. So how do we determine critical limits? There are several steps we should know about. First, identify the critical control points in your process where food safety hazard can be prevented, eliminated, or reduced to an acceptable level. And then, for each CCP, identify the specific hazards that need to be controlled. These could be biological, chemical, or physical hazards. Moving on, for each hazard, establish a maximum and/or minimum limit that must be met to ensure the hazard is adequately controlled. This could be a temperature range, a certain pH level, a maximum allowable concentration of a chemical, etc. After that, gather scientific data or regulatory standards like food and drug regulation that support your chosen critical limits. This could come from research studies, regulatory guidelines, or industry best practices. And in the fifth step, conduct experiments or gather further evidence to validate that your chosen critical limits are effective in controlling the identified hazards. And once your critical limits have been validated, implement them in your process and set up a monitoring system to ensure they are constantly met. And the last step, establish a plan for what to do if a critical limit is not met. This could involve discarding affected products, reprocessing, or other corrective actions. We will talk about this too in details later. And now let's look at some examples. So first is cooking temperature. We'll talk about this before, right? And the cooking of poultry, a critical limit could be an internal temperature of 165 Fahrenheit. This temperature is known to effectively kill common foodborne pathogens like Salmonella or Campylobacter. And then, when scanning foods, a critical limit could be a pH of 4.6 or lower. This is because most harmful bacteria, including botulism, cannot grow in acidic conditions, which is pH lower than 4.6. And in vegetable washing step, a critical limit could be a chlorine concentration of 100 ppm in the wash water. This concentration is known to be effective in killing bacteria, but not so high as to pose a chemical hazard. Okay, then we're going to talk about establish a system to monitor the CCPs. Let's talk about monitoring procedures. These are documented methods or protocols. They are the means by which we ensure the critical limits at each CCP are constantly met. They involve the ongoing collection of observations or measurements of control parameters to ensure that critical limits are met and control measures are functioning as intended. They are the primary means of verifying that the system is working as it should. So here are a few key points to understand monitoring procedures. First, what to monitor. This involves identifying the specific parameters that need to be measured or observed at each CCP. This could be physical measurements like temperature or time, chemical measurements like pH or salt concentration, or even microbiological tests. And then how to monitor. This involves specifying the methods or techniques used to monitor each parameter. This could involve using specific instruments, conducting visual inspections, or performing laboratory tests. And the third is when to monitor, or frequency. This involves determining how often monitoring should take place. The frequency should be sufficient to ensure that the CCP is in control. It could be continuous every instance or intermittent, like every hour, every batch. And the fourth, who monitors. This involves identifying who is responsible for performing the monitoring and recording the results. This is typically someone who is directly involved in the process and has been trained in the monitoring procedures. And the last, record keep. This involves keeping records of the monitoring results. These records are crucial for verifying the HACCP system is working and for identifying trends or issues that may require attention. Okay, for today's last part, establish corrective actions. First, what is corrective actions? These are the procedures that are followed when a deviation occurs at a critical control point. The purpose of corrective action is to regain control of the process and ensure that unsafe products do not reach the consumer. By having corrective action procedures documented ahead of time, a food production facility can ensure a swift and effective response to any deviations that occur, thereby minimizing the risk of unsafe food reaching consumers. and we should know about the steps to establish corrective actions. First, determine who will be responsible for taking corrective actions when a deviation occurs. This should be someone who understands the product, the process, and the preventive control plan. And then document what needs to be done to regain control of the process. This could include adjusting the process, isolating affected products, stopping production, conducting a safety assessment of the affected food, and determine the appropriate disposition of the food, like rework or destruction. And then the third, document the steps to be taken if the deviation affects the safety of other product lots that have already entered the marketplace. This could involve a product recall. And the fourth step, document the steps for determining the root cause of the deviation and preventing reoccurrence. This involves investigating what went wrong, implementing corrective actions, verifying their effectiveness, and adjusting control measures as necessary. And in the last step, prepare a standardized record to document the details of the corrective actions. This record should include information about deviation, the food safety assessment, the corrective actions taken, the completion of corrective actions, the root cause and control measures, and the verification of the corrective actions and control measures. Let's look at a real-life example. Let's consider a scenario where the internal temperature of cooked chicken, the HACCP, does not reach the critical limit of 165 Fahrenheit. So first, the chef or cook responsible for cooking the chicken is identified as the person who will take corrective actions. And then the corrective actions could include adjusting the cooking time or temperature, isolating the cooked chicken, and conducting a safety assessment to determine if the chicken can be recooked or if it needs to be discarded. And if undercooked chicken has already been served to customers, the restaurant might need to inform the customers and provide them with a replacement meal. And the restaurant investigates why the chicken didn't reach the correct internal temperature. Perhaps the oven wasn't preheated properly, or there was an issue with the food thermometer. The restaurant then implements corrective actions such as retraining staff on proper cooking procedures or purchasing a new food thermometer, and verifies their effectiveness. And in the last step, the restaurant documents all of these details in a corrective action record, which can be revealed later to ensure that the corrective actions were effective and to help prevent similar deviations in the future. So that's all for today. See you next time.